All right, so continuing with our similar triangles with angle. So remember the two angles need to be congruent, corresponding angles. So you ended yesterday with just working with a picture and kind of saying like, well, this angle is congruent to this one, or this triangle is congruent to that one. You'll just continue. You did, I think, 4 out of the 8 problems that were there. You'll just continue with those. And then you're going to do some application problems, which I kind of like because it's like how, okay, we've got this um, angle thing. Like, when would that ever be like useful? So here's a couple different uh, ways or different things that you can do that. So please excuse the crude drawing. Um, but so let's say you're standing here and there's this big flagpole, and you're like, gosh, I wonder how tall that flagpole is. So you really can't just measure up this, take out like a ruler and start measuring like this big, huge like flagpole. So, but we could use some other information. So, it's a sunny day. So you've got a shadow. There's a shadow of like the flagpole, however long it is. Um, and so you can measure that like on the ground, because even if you had like a big long tape measure, it's like on the ground. You're not having to go super high up in the air. So let's say that the flagpole's shadow was 50 feet. Um, and then we also had that you were 5 feet 4 inches tall, and that the shadow that you made was 40 inches. So essentially, if you were to make a triangle out of this like stuff, the sun is creating an angle. The sun needs to be up like higher, but the angle that the sun shines like down, this angle up here at the top would be the same. And then assuming that you're standing straight up, you have a right angle and a right angle. So you have two angles in the triangle that are congruent. And then therefore you have similar triangles. And we can set up a proportion to solve it. So, the proportion you can set up a few different ways. But, if we had the shadow and then the height needs to go with like the height. So, there's, again, you could do a lot of different, the shadow could go on top and like your height could go on the bottom. You could have the height and, the two heights and the two shadows. Like there's many different like ways to like set it up. So, you could have the shadow of one and the shadow of the other, and then the height of each. Just as long as like the top is like the height that you are in the shadow, and then the bottom is the shadow and the height of like the pole. There's, like I said, a lot of different like ways that you could do it. So the one thing that you will have to do is you'll have to do a conversion at like one point. So if we did this bottom one, so the shadow of the pole is 50 feet, and the shadow of you is 40 inches. And you might think, like, do we need to convert those? And I'll explain that like in a minute. And then the height of the flagpole is X feet, I don't know. And then your height, well, 5 feet 4 inches, we need to convert that to just inches. So 5 feet, 5 times 12 would be 60, plus 4 would be 64 inches. Okay, and so as long as you have inches across from each other and feet across from each other, you really are okay. Like you can multiply the numbers together, but if 3 out of the 4 were in inches and only one of them was in feet, then you would have to convert. Excuse me. So when we multiply the diagonals, kind of come up here, 40 times x is 40x, and 50 times 64 is 3,200. And then when we divide by 40, you get 80 feet tall for the flagpole. Okay, so there's one way that you could use similar triangles. Okay, and that example is in the book also, so if you wanted to read some more on it, you could. Another way to use similar triangles is, like, let's say we had a river, and we wanted to know, like, how far it was from one side of the river to the other. And again, you don't just get like a tape measure and go from one side of the river to the other side of the river. But we can set up triangles on either side. So if I kind of went back some amount and then went over some amount, I could create another like triangle like this. So if I said, well, I went, back 5 feet and then I went over 10 feet, I don't know. Well, you could measure this part over here on the top part of the river because you're on like the land. Someone would obviously have to be on the other side of the river to do that. But like and I'll get back to that in a second, what you've created, we have vertical angles here. And then we'd have right angles there. So we have angle. Triangles are similar. Okay, so let's say, we went back 5 feet and over 10 feet, and then over here was 80 feet. And we're trying to figure out that. So you could put, 5 over 10. And then the 5 is, along this line. So the x would have to go on that one. And then the 80 is the side to side, and that would go there. And then this one, you can reduce. Okay, and then, again, we talked about it the other day. If you notice, like, I could just do 2 times 40, so 1 times 40, and x would equal 40. If you multiplied the diagonals to solve it, you would get 2x equals 80, and then divide by 2, and x is 40. Okay, so 40 feet across the river. And so sometimes when people make maps, there's like survey equipment and stuff that do it like for you now. But that's another way that you could use similar triangles. Okay, so you'll have a few different problems kind of applying the similar triangle idea to some problems toward the latter part of your assignment. Okay, but you're just, again, draw pictures. There's some pictures already on a couple of them. But there's 4 problems where it says, is it possible for triangle JKL and triangle XYZ to be similar? Remember that they tell you JKL and XYZ in that order, so the orders have to match up. J goes with X, K goes with Y, L goes with Z. Draw pictures. There's no pictures on that. It just says angle this is 71 degrees and angle this is 52 degrees. And so draw pictures. It always makes it easier, in my opinion, to understand if you draw a picture. And it doesn't need to be super accurate. Just writing stuff down like that will be helpful. Okay, so it should be just 15 through 28. So not a ton of problems, but okay. And then you'll have a quiz tomorrow. Okay, so it's just over the 2 sections, similar polygons, and then similar triangles using angle. All right, have a great day. We'll see you tomorrow.